And before that, fundamental theorem of arithmetics. Natural number n greater than 1 can be factorized into its factors, and the expression is unique up to the order in which primes occur. Which help us to have the representation of any natural number in uniform fashion. Okay, so what is the use of writing the number in canonical prime factorization, or what is the purpose of factorizing any number? There are so many advantages. We will see them. Okay. So maybe 72. Suppose we want 72, then it can be written as आपण केलं होतं ना परवा 9×8=72, 2⁻³ 3⁻². And we have seen first application to check whether the number is perfect nth power or not. Yes. If canonical prime factorization has the indices of all prime numbers which are multiples of say 2, then it is a perfect square. They are multiples of 3, then it is perfect cube. If they are multiples of n, then it is perfect nth power. सगळ्यांना समजलंय? Anybody has any difficulty, doubt? The way we are talking about perfect nth power, we can talk about perfect nth root. So suppose any number n which is 2⁻⁹, 3⁻�6, 11⁻3, we can find out a cube root of this number. So cube root of n is going to be equal to 2⁻3, 3⁻2, 11⁻1. So this is the first advantage of having any number in prime factorization, which we have seen last lecture. Okay. Now we wish to find out. We said 360 has got 24 divisors. We would like to enlist. Let us start with a small number, 72. Can you tell me how many divisors? When we say divisors, when we talk about numbers, number theory is always talking about natural numbers, positive integers. Okay. Otherwise, there are rationals, irrationals, complex, so many number systems are there. But when we are talking about numbers, especially we call it as a number theory, without specifying, we assume that we are talking about positive integers, natural. So I want to know how many divisors of 72. हो, ते सगळ्यांना नाहीये माहिती. We can enlist, I mean, that is the easiest way because the number is small. We can keep checking. 1 divides 72, yes. 2 divides 72, yes. Like that, we can cross check and find out total number of divisors. That is the first way to start learning. I mean, just enlisting. That is the simplest method. But the problem with that is if that number is big number, then we will be in trouble in counting. So we will have to start with this. That is the first step. Start with counting, enlisting, and then try to find out the pattern and then generalize. So maybe 72 is a small number, so we will actually enlist and find out. Maybe we can take a little bigger number then find out, and then learn what is the pattern, and then maybe generalize for a big number, and then what Sir is saying, it is going to be a formula for finding out total number of divisors. Yes, if your answer is ready, you can show, show that you are ready. झाले.
दोन तीन चार पाच सहा सात आठ नऊ 10 1 0 1 0 10
Yes. सांगा तुम्ही. 12 divisors. How many divisors? 2. Okay, how many of you got answer 12? बरेच जणांकडे 1 2 3 4 आहे. It seems it is correct. Let us list 1 2 3 4 6
8
18
24
24
22
36
72
4 4 8 4 12. Correct. Let us keep these numbers over here.
Hello, sir.
Yes.
Sir, black background can be used. Black.
नाही काय प्रॉब्लेम यायला नाही. आय मीन दिस बोर्ड इज ॲज इट इज विजिबल ऑन युअर कॉम्प्युटर.
थोडस ते व्हाईट ग्रीन वरचं व्हाईट थोडं क्लिअर नाही वाटत आहे मला.
हो
ते
का?
वरचं रूट एन ते दिसत नाहीये काय लिहिलंय ते.
बरं ठीक आहे.
हा, थँक्यू सर.
नाही, आय एम नॉट चेंजिंग द बॅकग्राऊंड, आय एम चेंजिंग द फॉन्ट साईज.
ओके, विल डू सर. थँक्यू.
सर मला एको येतोय.
तुम्हाला ऐकतोय?
इज एनीबडी गेटिंग एको?
त्यामध्ये तुमचा माईक तुम्ही बंद करा आणि चेक करा एकदा. बाकीच्यांना येतोय का एको? का माझं क्लिअर येतंय सगळं ऐकायला?
क्लिअर आहे सर.
क्लिअर आहे सर.
क्लिअर आहे सर.
ओके. This is third root of n. Is it visible now?
यस सर.
पांढरं पण छान दिसतंय सर.
आहे, वेगवेगळे कलर आहेत माझ्याकडे, भरपूर कलर आहेत. वापरू आपण एक एक एक. ओके, सो नाव द पॉइंट इज हाऊ डू वी अराइव्ह ॲट दिस दॅट इट इज 12. what do we do is the obvious step. अजून येत आहेत. कधी थांबणार आहे? पहिले 8 लेक्चर मला वाटतंय की मला डोकं शांत ठेवायला लागेल. बर, काम करूया. We will write prime factorization of all these people. Okay, 1, how do we write 1? We know that in 72 there are 2 prime factors, 2 and 3. So let us write 1 as 2 raised to 0, 3 raised to 0. This is 1. 2, 2 raised to 1, 3 raised to 0. 3, 3 raised 2 raised to 0, 3 raised to 1. 2 raised to 2, 3 raised to 0. 2 raised to 1, 3 raised to 1. 2 raised to 3, 3 raised to 0. Then किती झाला आपला? 8, 9. 2 raised to 0, 3 raised to 2. This is 8. This is 9. Then 12. 2 raised to 2. 3 raised to 1. 18. 2 raised to 1. 3 raised to 2. 24. 6 चौक 24. 8 त्रिक 24. 2 raised to 3. 3 raised to 1. 36. 2 raised to किती? 4. 8 चौक 32 नाही 2 raised to 2 3 raised to 2. Okay, perfect square. 72 2 raised to 3 3 raised to 2. These are the prime factorizations of all the divisors. Now I need not tell you anything, and you will come to know how do we find out total number of divisors. We start with 2 raised to 3 3 raised to 2, and we get these many divisors. Now they are written in horizontal form. Maybe we can write them in a better way, disciplined form. If we can write them in disciplined form, let me try. 2 raised to 0, 3 raised to 0, 2 raised to 1, 3 raised to 0, 2 raised to 2, 3 raised to 0, 2 raised to 3, 3 raised to 0. All these four guys are present in this. 2 raised to 0, 3 raised to 1, 2 raised to 1, 3 raised to 1, 2 raised to 2, 3 raised to 1, 2 raised to 3, 3 raised to 1. These people are also present. बरोबर आहे. आणि 2 0 3 raised to 2, 2 raised to 1, 3 raised to 2, 2 raised to 2, 3 raised to 2, 2 raised to 3, 3 raised to 2. You start with 2 raised to 0 0, 3 raised to 0. You end with original number. If we organize them in this fashion, then we come to know why they are 12. येते सगळ्यांच्या. त्यामुळे देर इज नो फॉर्म्युला टू बी रिमेंबर्ड. Every formula can be derived. Somebody else has already done that work. Therefore, we use formula directly. 2 raised to 0. This entire row is of 3 raised to 0. This row is of 3 raised to 1, 3 raised to 2. So there are 3 rows and 4 columns. So if we look at this, okay, instead of starting 1, we start from 0. So we get 3, 0, 1, 2, 3. We get 2, 0, 1, and 2. So 4
Sir?
because
Hello,
of
sir.
3 column, 3 rows because of 3. Yes.
सर याच्यावरून आपण असा फॉर्म्युला लिहू शकतो की नॅचरल नंबर n इज इक्वल टू p रेस टू i इंटू q रेस टू j, i रनिंग फ्रॉम 0 to 3 and j रेस टू 0 to 2.
हो हो लिहू शकतो. ठीक आहे. ओके, चांगली गोष्ट आहे. So almost everyone knows why 12 now. So if I give, do you want me to explain? So we just look at the prime factorization of a given number, which is compulsory. We have to do it. We do not know what that number is. The moment we know the prime factorization, we get to know total number of divisors. Simple. Add 1 to the first index, multiply by, add 1 to the second index, and if there are more than one. So let us say n is equal to, okay, let me give you practice for factorization. So your factorization is the first hurdle. You should get it correct, and then only your number of divisors are going to be correct. So n is equal to 18,000. Get me the total number of divisors. Now you have to show. If you have slates, it is good. Otherwise, I cannot see your answer. You have to tell me how many divisors 18,000 has. Now, instead of raising hand, you can show your answer. Koteshwar sir, correct. We are supposed to show. If we spell out the answer, others will try to match their divisor's exact number. Yes. Anup sir, correct.
Sir, please check my answer.
Sir, check mine too.
Wait, I have got a couple of screens in front of me. Deepika is showing me the prime factorization. I want total number of divisors. Let me check. Somebody else is showing the answer. Go to the second screen. Amruta madam, that is not correct answer. Madhura madam, please bring your notebook closer to the camera. Correct.
Sir, I have
Correct.
shown
Now you
the
fix
answer
the
in the
position.
chart.
If I keep my notebook at this position, then it is visible. Yes, Vaishali
Sir-
madam, correct.
Yeah, sir, my answer is in the chart.
Your answer is in the chart. Shubhangi madam, if that number is 80, then it is not correct. Okay, then. Okay, now third screen. Sonali madam, show me your answer only. Difficult. Closer to the camera. अजून आता डावीकडे घ्या, वही डावीकडे घ्या. करेक्ट. आता लक्षात ठेवा, कुठे धरली की आन्सर दिसतं. So now this is two-step question. If student does both the steps correctly, then the answer is correct, otherwise difficult. So any difficult question has more number of steps. And at each step your concept must be clear, then only you will get the final answer correct. I don't know why it is very difficult for me to see the answers. Anyway, the prime factorization of 18,000 is, पांढरं चांगलं दिसतंय, 2 raised to 4, 3 raised to 2, 5 raised to 3. Okay, therefore number of divisors equal to 4 plus 1 into 2 plus 1 into 3 plus 1, which is equal to 60. Why 4 plus 1? Because index of 2 will start from 0 and stop at 4. Index of 3 will start from 0 and stop at 2. Index of 5 will start at 0 and stop at 3. Why we cannot have 2 raised to 5 in our divisors? Because this number 2 raised to 5, 3 raised to say 2, 5 raised to 3 is going to be bigger than the given number. So we cannot have index bigger than what is the big number. I mean, the biggest number in the list is the number itself. We cannot have a divisor which is bigger than the number, because multiple is 1. And hence we can start with 0, but we have to stop at whatever x is of that prime factor. So this is simple. Once the trick is known, then the formula is known. No matter how many prime factors are there, suppose n is equal to 2 raised to 3, 5 raised to 4, 7 raised to 2, 11 raised to 5. Then total number of divisors will be 3 plus 1 into 4 plus 1 into 2 plus 1 into 5 plus 1. Whatever that answer is, and that is going to be correct answer, because we can put all of them into a box, very nicely, disciplinedly organized box, and the counting will become very easy. So this is another application of prime factorization, finding total number of divisors. Okay. Then I would like to know that there are 60 divisors of the number 18,000. We want to find out the sum of those divisors. Add all of them and tell me the answer. It's going to be a very difficult and a big question, because 18,000 is a big number. Okay, so let us do it for 72, because you have 12 factors or 12 divisors of 72. I am asking you to add all of them and let me know what is the number. What is the sum of the divisors of 72? Find sum of the divisors of 72.
सर ते बेसिकच अडलेलं आहे माझं. ते तुम्ही एकदा सांगता का सर पुन्हा प्लीज?
सर आन्सर चॅट मध्ये आहे.
नाही, मी चॅट वगैरे आता बघूच शकत नाहीये. हा बेसिक काय अडलंय जरा सांगा प्लीज. सगळ्यांना जे शिकवतो आता ते खरं म्हणजे सगळ्यांना कळायला हरकत नाही.
तर थोडं वर गेलं ना तर ते 18,000चे तुम्ही 2 raised to 4, 3 raised to 2 आणि 5 raised to 3 ते कसे करता एकदा सांगता का मला प्लीज?
हा, ओके. हाऊ डू वी फॅक्टराइज अ गिवन नंबर इज अ क्वेश्चन.
Yes, sir.
आता मी करून दाखवतो, म्हणजे कदाचित शाळेत आपण कसं करायचं ते आठवेल आपल्याला. हा, आणि नंतर मग मी समजावून पण सांगतो ऍक्च्युअली कसं करायचं ते.
हो सर.
सो 18,000 एंड ला 0 आहे, सो इट इज डिव्हिजिबल बाय 2. बरोबर. आता इथे डिव्हिजिबल बाय 2 मी म्हटलं तर इनडायरेक्टली युजिंग डिव्हिजिबिलिटी टेस्ट ऑफ 2. Okay, so the last digit, if the last digit is even, then the number is going to be divisible by 2. So this is going to be 9,000 if we divide by 2. 9,000 also happens to be divisible by 2. 4,500. 2. बेदुने 4, बेदुने 4, बेपंचे 10, 2. बेदुने 4, बेपंचे 10. Okay. Now this number is not divisible by 2, but it is ending with 5, so it is easy. Divisibility test of 5. If the number is ending with 0 and 5, it is divisible by 5. I write 5. 5 दुने 10, 5 दुने 10, 5 5 25. म्हणजे असं हा म्हणजे, but I think the first visible is 5. शेवटी प्राइम फॅक्टरायझेशन लिहिताना कॅनॉनिकल लिहूया. फॅक्टर पाडताना जे ऑब्वियस आहेत ते पटापट पाडून घेऊया. ओके. 225 ऑल्सो इज एंडिंग विथ 5. 5 चोक 20, 5 5 25. 5 9 5 25. ओके. 3 आणि 3. ओके, कळलं? जे डाऊट विचारत होते त्यांना फॅक्टरायझेशन कसं करायचं ते कळलं?
कळलं सर. थँक्यू.
आता याच्यासाठी तुम्हाला आवश्यकता लागणार आहे, हे सगळे सोपे होते. आवश्यकता लागणार आहे ते डिव्हिजिबिलिटी टेस्टची, त्याच्यावर आपण डिटेल डिस्कशन करणार आहे. हो, त्यांना काहीच समजत नव्हतं ना, म्हणून एक प्रोसिजर दाखवली. We can do it in more than one methods. If we are good at factorization, maybe by seeing the number also we can write the factorization. But if we want to perform the complete procedure, then this is the procedure. Now, only thing which is not clear here is how do I know that 18,000 is divisible by 2? For that I need to know the divisibility tests. Divisibility tests are the efficiency test. Actually we did not divide and आता याला मी समजा 7, I thought 7 is a factor of 18,000. How do I know whether it is factor or not? I should actually perform division by 7 and then end up having some remainder and realize that no. 7 is not a prime factor of this. It is time consuming. Therefore, our forefathers have designed a divisibility test so that your time is not wasted. The moment we see 0 divisible by 2, 5 divisible by 5, 9 divisible by 3, something like that. So we will learn all possible divisibility tests. You name the number, we will discuss the divisibility test of that. Okay, not that only what is given in textbook. We will discuss divisibility tests in detail so that whichever prime number that you have in your mind, we will have a divisibility test for that. Now, only problem is if the divisibility test application takes lot of time and energy, it is sometimes better that you actually divide and check. It is easier. Therefore, we have to stop at some point as far as divisibility tests are concerned, but test can be designed. We will see that. So this is the way you should get the prime factorization. After you get the prime factorization, looking at the indices of these primes, we will be able to find out total number of divisors. Now the question is, how do we find out sum of those divisors? How do we find the sum of those divisors? Now, see, these are the questions which somebody is listening for the first time thinks that it is very difficult, and it is difficult. But if we start getting into the theory, start getting into the process, how we have derived all possible divisors, yes, there is a disciplined way. Matrix is there. There is a 3 by 4 matrix over here because there were only 2 prime factors. Now, therefore, I am asking you the summation of divisors of 72. One way is to start adding 1 plus 2, 3, 3 plus 3, 6, 4, 10, 16, and so on. But if the number is big, we will end up getting mistakes there, or we may not be able to complete the calculations if the number is big. So maybe this method is good for small numbers. As far as finding out total divisors are concerned also, maybe this is fine, easy. But if it comes to n few big number, then this is the system by which we do it. So maybe for divisor summation also we use this system. We have all the divisors with us, all 12 of them, and we want to have a sum. Suppose we add the first column. What will happen? 2 raised to 0 will come out common inside bracket 3 raised to 0 plus 3 raised to 1 plus 3 raised to 2. We can do it for first column like this. 2 raised to 0 is 1, but I am deliberately taking it as common. Then I am supposed to add. I have already added column. So now I am supposed to add the summation of column 2. So I take 2 raised to 1 common inside bracket 3 raised to 0 plus 3 raised to 1 plus 3 raised to 2 plus 2 raised to 2 common inside bracket 3 raised to 0 plus 3 raised to 1 plus 3 raised to 2 plus 2 raised to 3 common inside a bracket 3 raised to 0 plus 3 raised to 1 plus 3 raised to 2. This is one part of the story. Still, this is not easy. This is still big and difficult. However, we can take a next step because every bracket is same, because they are disciplined, they are arranged in a very disciplined manner. All the brackets are same. We can take the bracket common. So 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3 multiplied by 3 raised to 0 plus 3 raised to 1 plus 3 raised to 2 is going to be your answer. And then we have to do the calculations. This is equal to 1 plus 2 plus 4 plus 8 into 1 plus 3 plus 9, whatever is the answer. That is how we should do it efficiently. 10 आणि 5 15 गुणिले 13 13 5 65 6 13 190 195 is going to be your sum. Now, in our school education system, they will have this in their syllabus, but they will either generate some formula and tell them like 180 into n minus 2 is known to all students, sum of interior angles, but how it has arrived, how they have arrived at that formula, nobody knows. Similarly, this is a very difficult question in number theory, finding sum of the divisors. But the moment we know the trick, I will not ask this question in your exam because it is very easy. We know the trick now. Okay, any question? आता कसं आहे की आज पण भरपूर आहेत लोक 90 plus, but I can see 25 students at a time, 25 windows. So it might be possible that some of you are attending but not understanding. आपल्याला तर आता काय लाजायची काही गरजच नाही ना, जे समजलं नाही ते विचारून टाकायचं. जास्तीत जास्त काय होईल, ओके इट इज इझी डाऊट ऑर समथिंग लाईक दॅट. पण या 8 लेक्चर्स मध्ये तुम्हाला जर काही कळलं नाही तर विचारायला पाहिजे. कारण मला आता कसं आहे की काही काही गोष्टी आय एम अज्युमिंग दॅट दे आर देअर, पण त्या कदाचित नसू शकतील. ओके, especially those who are teachers, they want to continue teaching this content to their students in their school or in their classes or whatever they are doing in education. You have to be absolutely clear. That is the whole purpose of this training program, no matter how much time it takes. Okay. Yes.
Sir. Hello, sir.
हा, त्यांना प्रायोरिटी दिली. बोला बोला.
Sir, I joined late actually, 5 to 10 minutes. तर माझं थोडं सुरुवातीचा पार्ट मिस झालतंय. तर नंबर ऑफ डिव्हिजन जे फाइंड आउट करतो त्याच्याबद्दल, तर मी हे ट्रेलिंग जे झालं त्याच्यावरून एक अंडरस्टँडिंग केली आहे, पण मला स्टील आय एम कन्फ्युज की मी करेक्ट आहे की नाही. तर आधी आपण प्राइम फॅक्टरायझेशन नुसार अजून पॉवर्स आणि म्हणजे जे फॅक्टर्स आहेत ते काढले आणि ते त्यांच्या इंडायसेस मध्ये +1 करत मग त्यांचा प्रोडक्ट काढून आपल्याला नंबर ऑफ डिव्हिजन मिळतील का सर?
हो. आता 2 प्रॉब्लेम सांगितलेत तुम्ही. एक म्हणजे तुम्ही लेट जॉईन झालात आणि
Yes, sir.
दुसरा म्हणजे त्यामुळे तुम्हाला समजलं नाही. तर त्याच्यावर
that's-
2 उपाय आहेत. 2 उपाय आहेत त्याच्यावर. एक म्हणजे पुढच्या लेक्चर पासून ऑन टाइम जॉईन व्हा आणि
Sir.
आता जे पहिल्या 10 मिनिटात समजलं नाहीये ते मी रेकॉर्डिंग टाकल्यावर तेवढं बघा.
Yes,
है
sir.
ना, म्हणजे 100 एक लोक आता अटेंड करतायत ना, त्यांचा सगळ्यांचा वेळ वाया नको जायला.
Yes, sir. Yes, sir.
हा, थँक्यू. बरोबर आहे, पण तुम्ही व्हॉट एव्हर यू हॅव गेस्ड इज करेक्ट.
Yes. Thank you, sir.
हा हा.
सर एक मिनिट हा, ते प्रत्येक वेळी टोटल काढताना सम ऑफ द फॅक्टर्स काढताना ते मॅट्रायसेस तयार करावेच लागेल का?
Nahi, very good question. If the prime factorization itself has got 10 primes with their different indices, then again we will mess up in writing those matrices. Because now if there were 2 prime factors, therefore matrix has dimension 2 by 2, 3 into 4. But if we have 3 prime factors, then it is going to be a box. If we have 4, we don't imagine how it is going. It is going to be multiple boxes, more than 1 boxes, and so on. Okay. So once we understand how do we do it, then we can arrive at this stage directly. We can arrive at this stage directly. Let me tell you, 2 raised to 3 3 raised to 2, 5 raised to 1, whatever is this number. What is the sum of the divisors? Sum of the divisors is 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised
Oh,
to
okay,
3
okay, okay, okay. Mhm.
into 3 raised to 0 plus 3 raised to 1 plus 3 raised to 2 into 5 raised to 0 plus 5 raised to 1. This is the sum of the divisors. We need not have to go back and keep drawing all those boxes, etc. They are there in our mind. If somebody asks you, this formula is wrong, can you prove it? Yes, we can prove it. But if we are just using formula and somebody asks that this is half base into height is wrong, then we do not know why it is correct. Area of triangle half base into height is wrong. Somebody challenges us. Then we do not know why it is correct. It is our job as a teacher that we know everything. And as per students' requirement, we are supposed to give those students whatever they need. But it was a very good question. I missed it. Because it was 2 by 2, it came like this. But even if that 2 by it is not 2 by 2, it is 3. And then if we have 10 prime factors here, there will be 10 brackets. 10 brackets. Correct आहे.
So,
3 वाले लिहून दाखवू का मी? बॉक्स.
आम्ही 1800 करून बघू का?
एक मिनिट. आता 3 वाला आपण डिसिप्लिन लिहायचा कसा असा प्रश्न आहे. 2 raised to 3, 3 raised to 2 आपण लिहिलाय. 5 raised to 1 राहू द्या. 18,000 मोठं होणार ते खूप वेळ जाणार. 2 raised to 3 आणि 3 raised to 2 चा लिहिलेला आहे 4/3. बरोबर आहे. आता 5 raised to 1 ऍड केला त्याच्यात. बरोबर. तर 5 raised to 0 वाला एक आणि 5 raised to 1 वाला एक. म्हणजे 3/3 चा जो आपला मॅट्रिक्स होता 3/4 वाला त्याच्यात आपण 5 raised to 0 आहे असं ऍझ्युम करू शकतो. कारण 5 raised to 0 is 1. त्यामुळे तो मॅट्रिक्स आहे तसाच. आणि अजून एक लेअर आपण मागे लावूया त्याच्या जे 5 raised to 1 वाली लेअर आहे. म्हणजे सगळे अगोदरचे 12चे 12 जे होते त्यांना 5 raised to 1 ने मल्टिप्लाय केलं. म्हणजे 5 ने मल्टिप्लाय केलं. आता 5 raised to 2 असता तर आपल्याला अजून एक लेअर लावायला लागली असती अशी मागे. म्हणजे आता एवढे सगळे जर पॉइंट दाखवायचे झाले तर ते समोर दिसतील इथे पहिल्या प्लेन मध्ये असे. पण मागच्या प्लेन मध्ये जरा अवघड जाईल आपल्याला. त्यामुळे वी अंडरस्टँड हाऊ इट इज. दिस इज अ 3-dimensional पिक्चर. Box, if we have 3 primes, if we have 4, then one box followed by another box. 4 primes. If we have 5 primes, then set of one boxes and another set of similar. Every time you are supposed to change the next. And actually we need not have to worry about that. It will work. It will happen. So for understanding, we are creating this matrix or a box, but then end of the day, finding out summation of all divisors, this is going to work. Vertical, you add them column by column and add all the columns. It is going to fall in place. Okay, any more doubts on this? Do you want me to give you one more example where you find out? Okay. चला एक मी प्राईम फॅक्टरायझेशन करूनच देतो का नको ते पण करता येते की नाही ते बघूया. Find number of factors, divisors, and sum of all divisors. काय झालं दिसत नाही. सॉरी कोणीतरी आला ना. हा
72 divisors.
हा मॅडम, कागदावर लिहा आणि दाखवा मला. तुम्ही काहीतरी डाऊट विचारत होता, तो झाला का सॉर्ट आउट? हा. ऍप्लिकेशन त्याचं नाही बरं. असं काय म्हणजे इट इज अ व्हेरी गुड क्वेश्चन.
Sir,
हा हा. नाहीये विजिबल.
okay.
अजून कॅमेऱ्याच्या खूप जवळ वही आणायला लागते तर दिस.
Okay, I will.
नाही असू द्या, काही प्रॉब्लेम नाही, ठीक आहे. अदर्स आर फाइंडिंग आउट, सो यू कॅन वेट.
सर माझा आन्सर दिसतंय?
नाही
सर माझं दिसतंय.
नाही दिसत. मी तुम्हाला नंतर एक ग्रुपवर फोटो पाठवतो, म्हणजे मुलं कसं दाखवतात ते तुम्हाला दिसेल. हा आता कोणाचं दिसतंय? जैन मॅडमचं दिसतंय. ओके. नाव आय हॅव नॉट कॅल्क्युलेटेड. लेट अस क्रॉस चेक विथ अदर्स मॅडम. 60.
माझं पण सेम आलंय.
हा जैन मॅडम, तुमची पाठी काढून घ्या, बाकीचे बघतायत.
Sir, I don't understand Marathi. बघा बरं visible
दॅट इज
आहे
गुड.
का? Sir,
येस. नाही आता एक मिनिट, मी तुम्हाला दाखवतो कसं दाखवायचं ते. हे बघा, आता मी इथे मला टोटल नंबर ऑफ डिव्हायझर्स मी लिहिले आणि मला माझं विंडो दिसतेय, तर मी सुरू करणार हळूहळू कॅमेऱ्याच्या जवळ न्यायला. हा आता सगळ्यांना दिसतंय की नाही माझा आन्सर? माझा चेहरा नाही दिसला तरी चालेल, आन्सर दिसलं पाहिजे. आता जेव्हा मी आन्सर दाखवतोय, यू मस्ट शो युअर आन्सर लाईक दिस. नाव इफ यू आर शोईंग युअर आन्सर लाईक दिस, देन इट इज नॉट विजिबल. When we are showing answer, your face is not important. हा मलाही सवय नाहीये, पण असं दाखवता येईल. हे बघ, हा झालं ना.
तर माझं दिसतंय का?
हा एक मिनिट, समचं जरा प्रॉब्लेम आहे. नाही म्हणून ती पाठी लागते. मी तुम्हाला फोटो दाखवतो मुलांचा. अरे बाप रे, सगळं कॅल्क्युलेशन दिसतंय सगळ्यांचं, त्यामुळे वाचता काहीच येत नाही.
सर माझं दिसतो?
येस कोटेश्वर सर, करेक्ट. करेक्ट. Now one by one, let me check one by one.
sir,
अवघड आहे.
sir,
नाही. It is difficult. You have to come offline. It is difficult to see the answers of 90 people who are online, and I have around 20 students.
सर माझं दिसतंय का? सम केलंय मी.
हा कोण, एक मिनिट. शीतल मॅडम टोटल डिव्हायजर्स कळतंय. अर्पिता मॅडम सम बरोबर आहे.
सर
माधुरी मॅडम नंबर ऑफ डिव्हायजर्स करेक्ट.
सर सम ऑफ डिवायझर्स बरोबर.
पाटील मॅडम तुमची अख्खी वही दिसते मला, त्यामुळे उत्तर दिसत नाहीये. अजून जवळ आणा. ओके, नाव इट इज टेकिंग टाइम. सम चुकी. ओके ओके, नंबर ऑफ डिव्हायजर्स 72. Okay, can we confirm the prime factorization? 2 raised to 3, 3 raised to 2, 5 raised to 2, आणि 7 raised to
7, 1.
Now, unless, okay, because these are easy, you will arrive at final factor 7 when you go on factorizing. But if we end up with something like 93 or some 91, then you need to know the divisibility test of 7. ओके, म्हणून मी आता, तुम्ही सुरुवात आहे, पुढच्या लेक्चरला पण यायला पाहिजे म्हणून 7:1 ठेवलाय. लक्षात घ्या, वी कॅन इन्क्रीज द डिफिकल्टी लेवल बाय डिक्रीजिंग इझी फॅक्टर्स अँड इन्क्रीजिंग डिफिकल्ट फॅक्टर्स. Therefore, those divisibility tests will be required. Okay, and sum of divisors will be 2 raised to 0. आता हा इथे पण एक ट्रिक असते. 1 plus 2 plus 4 plus 8. This is geometric progression multiplied by 1 plus 3 plus 9 multiplied by 1 plus 5 plus 25 multiplied by 1 plus 6. किती 48,000 360. 48,360 is the answer. समजतंय सगळ्यांना? हे भारी आहे एकदम.
हो सर.
आता याच्यापेक्षा जास्ती न्यूमरिकल क्लासमध्ये करणं म्हणजे वेळ वाया घालवणं. जर समजलं नसेल तर विचारा. काय झालंय आतापर्यंत ते समजलं नसेल तर विचारा. इफ यू आर अंडरस्टँडिंग एव्हरीथिंग व्हेरी गुड, वी नीड नॉट हॅव टू सॉल्व्ह मोर देन दीज मेनी प्रॉब्लेम्स ऑन दॅट कन्सेप्ट इन क्लास. इट इज वेस्ट ऑफ टाइम.
सर
येस.
सर मला नाही समजलं, तुम्ही ते 1 + 2 + 4 + 8.
हा, असं का केलं? Normally, see, why I am doing this is, as a teacher, you should know when students are not going to understand. Muddamun, I am taking some jumps so that few of you do not understand why it is happening. And then you are supposed to stretch yourself. That means your thinking process is started. Okay? 1, 2, 4, 8 is correct. Nobody is objecting. Then it must be correct. But suppose I am not understanding, what could be the step before this? Okay, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on. This is what it is. It is perfectly logical. समजलं? Okay. Now, at what stage you are teaching is important. Normally, when we teach in our institute, we tell students that majority of the calculations need to be done in brain and minimal has to be done in the notebook. It is exactly opposite in school. Okay. You will not be able to complete the IIT advanced paper if you keep writing each and every step for finally arriving at the answer. It is going to be too time consuming. Therefore, till last problem I explained you this, but now this step is also not required. The moment we have prime factorization, we can directly have sum of the divisors like this. Minimal waste of energy, maximum in mind. Okay, very important. And that has got several other advantages also, which at student level definitely matter the most. Okay, let us leave this divisors and sum of the divisors behind. Just in brief, 2 raised to 3, 3 raised to 4, comma, 2 raised to 2, 3 raised to 5. These are the two numbers given to us. तर आपण यांचे आपल्या ओळखीचे फॉर्म काय आहेत? 3 त्रिक 9 त्रिक 27 त्रिक 81 गुणिले 8, 864, 648 and 3 त्रिक 9 त्रिक 27 त्रिक 81 गुणिले 3, 24 to 43 गुणिले 4. त्रिक 9 त्रिक 27 त्रिक 81 4 5 243 4 त्रिक 12 2 आजचा 1 4 4 16 आणि 1 17 4 2 8. Okay. If these two numbers are given to us, which are relatively big, and if we are required to find out the least
Sir, 970.
972 sir.
972.
972.
4 2 8 आणि 1 9. Sorry.
972.
And if we are supposed to find out least common multiple, and another thing that is asked is greatest common divisor. So let us work on divisor first, because we have been working on divisor. So see, this is extremely difficult. 648,972, find GCD, greatest common divisor. Now we have listed all possible divisors of every natural number that is given to us. Now we are supposed to compare these two numbers, their divisors. There will be few common. Among the common divisors that we have, which one is the greatest? That is what we are supposed to report. Okay. Fortunately, we have prime factorization of these numbers. And the method that we have used to enlist our divisors is going to give us this answer very fast. Tell me, what is GCD of these two numbers?
324.
Tell me means show me. Show me GCD of these two numbers. Don't tell.
হ্যালো, হ্যাঁ আমার ওই কল চলছে বলে তোমার আপডেট দিতে পারিনি। ও খেলে না ওই পথে দাদু ঠাম্মার ওখানে চলে गए.
Somebody from Kolkata. नॅशनल लेवलचा ट्रेनिंग प्रोग्राम चालू आहे. सांगतोय, होऊ दे सगळ्यांना.
So are you able to see?
सर
येस.
झालंय सर हे.
हो, चांगली गोष्ट आहे, सगळ्यांचं होऊ द्या.
प्लीज चेक कराल का?
माझी वही दिसते का?
नाही दिसत आहे.
माझं दिसतंय सर.
नाही.
आता
दिसतंय सर?
हा, जीसीडी दाखवते ना. ओके.
हो जीसीडी.
अर्पिता मॅडम करेक्ट. दुला मॅडम करेक्ट. हा, जैन मॅडम करेक्ट. बाकीच्यांचे जे दाखवतात त्यांचे दिसत नाही. थांबा, दुसऱ्या स्क्रीनवर जाऊ. हा, दुसऱ्या स्क्रीनवर पांडे रोल नंबर 33 करेक्ट. माधवी मॅडम करेक्ट. वैशाली मॅडम करेक्ट. बाकीच्यांचं दिसत नाहीये या स्क्रीनवर. पुढे लास्ट स्क्रीन. हा, मधुरा मॅडम करेक्ट. बाकीच्यांनी क्लोज. तुम्ही कॅमेऱ्याच्या जवळ वही घ्यायला एवढं घाबरताय कशाला? घ्या बिंदास.
दिसतंय सर?
नाही. प्रिया मॅडम करेक्ट. बाकी इकडे यांचं कोणाचं दिसत नाही. अनु मॅडम दिसत नाही. सीमा मॅडम नॉट विजिबल.
माझं दिसतंय सर.
वेट. या स्क्रीनवर अमृता मॅडम करेक्ट आणि अविनाश सर नॉट विजिबल. शुभांगी मॅडम करेक्ट आणि नितेशा मॅडम करेक्ट. थांबा, आता ऑफलाईन वाल्यांचं बघतो जरा, त्यांच्याकडे लक्षच दिलं जात नाहीये. हा सर, दिसत नाही मला. कोणाला डोळ्याचा प्रॉब्लेम आहे का? हा, 442 कुठचं तिथे का? 972. सॉरी, तुम्ही समोर असं मध्ये बसा ना. हा, बघायचं का? बघतो. येस. बरोबर. करेक्ट. 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 करेक्ट.
सर LCM दिसतोय.
थांबा आधी मी ऑफलाईन वाल्यांचा चेक करतोय. करेक्ट. म्हणजे ते मी सांगत नाही आता ऑटोमॅटिक ते इव्हॉल्व होणार आहे. इव्हॉल्व होणार. हा. म्हणजे जीसीडी काढताना लोक काय करतात तो विचार आपल्याला करायची गरज नाहीये. आपल्याकडे सगळे डिव्हायझर्स आहेत आणि त्यातले कॉमन शोधायचे आणि त्यातला सगळ्यात मोठा शोधायचा. त्यामुळे त्या प्रोसेस विल इव्हॉल्व. ते फॉर्म्युला किंवा मी सांगतोय म्हणून काही गरज नाही ऐकायची. हा. स्क्रीन नंबर 1. भावना मॅडम करेक्ट.
सर LCM दिसतोय का?
थांबा जरा आधी जीसीडी बघूया.
सर दिसतंय.
नाही. ओके. सो in the list of divisors of 648, this is going to be the biggest number and there will be किती 4 पंचा 20 20 divisors and the smallest will be 2 raised to 0 3 raised to 0. ज्यांना समजत नाही त्यांनी नीट लक्ष द्या. ज्यांना समजलंय ज्यांनी एलसीएम पण काढलाय त्यांनी शांत राहा. Then there will be a list of this. There will be a list of this. Because of 3 raised to 5, there will be few divisors which will not be present here. Because of 2 raised to 3, there will be few divisors of 648 which will not be present here. बरोबर आहे? And all the indices of the divisors begin from 0 and stop at the index of that prime factor. So, as far as now we are finding out GCD, so let me write down GCD's prime factorization also will be having same primes. So 2 and 3 will be the primes present in the GCD. Now, I will look for shall I look at 2 raised to 2? 2 raised to 2 is going to be available in this divisors, list of divisors. But 2 raised to 3 will not be available here. So if we are looking at common divisors, I should look at 2 raised to 2 as my biggest power. 2 raised to 1 will be available here as well as here. 2 raised to 0 will be available here as well as here. 2 raised to 2 will be available only here, not here. Sorry, here and here. 2 raised to 3 will be available only here, not here. Similarly, 5 raised to 5, 3 raised to 5 will be available only here, not here. Therefore, if I want a common divisor in the list of divisors, I should take the smaller amongst the two by comparing them. Therefore, I will write 2 here. Similarly, I should take smaller amongst these two. 4. This is the GCD, common divisor, greatest amongst them. If we write any index lesser than this, will it be divisor? Yes. Will it be common? Yes. But is it greatest? No. त्यामुळे छोटा इंडेक्स शोधायचा संपूर्ण. मग मी तुम्हाला 10 नंबर्स दिले असतील टोटल. And if you want to find out GCD of 10 numbers, then you are supposed to prime factorize, compare all the indices and take the smallest. There could be possibility that both of them are same. Doesn't matter, we have to use the same over there. Common multiple. Common multiple is you multiply the given number by natural number, you will get first. Suppose I multiply this by 2, I will get the first multiple of 648. If I multiply by 3, then I will get second multiple of 648. So actually the multiples are too many, infinitely many. Because we can multiply 648 by any natural number and natural numbers are infinitely many. Therefore, there will not be any list in which we compare and find out which is the least. this is going to be too big. Multiples are going to be too big in number. Why they will be too big? Because you can write any power of 2 and any power of 3. It is going to be multiple of both these numbers. Bigger than say 5 and 3, it is going to be multiple. बघा समजतंय का? If I want to write down, suppose 2 raised to 7 and 3 raised to 9, is this going to be multiple of this number? Yes, because this number is a divisor of this. Okay, if we have understood divisor better, then we can look at it like this. If you want to find out all the divisors of this number is going to be there. Will this number be there? Yes, this number also will be there. Because both the indices are bigger than the indices of those numbers. बरोबर आहे? त्यामुळे this is going to be the one of the multiples, not necessary the least. Okay. So this is too big compared to these two, and it is two bigger multiple. So if we want to optimize and find out the least amongst them, then we will have to play with these indices again. LCM is equal to, take the bigger index 3 raised to. So that is the simplest way of finding out GCD and LCM. We have many methods in textbooks which we should learn and explain, but this is the method of finding out GCD and LCM. Now, the moment we understand this, there are many questions which can be designed for GCD and LCM. There are many very, very difficult questions also can be designed based on this concept. However, the understanding is absolutely simple. You take the smaller index for finding out GCD of smallest amongst available indices for GCD, and largest amongst available for LCM. Okay. So what will you do in this case if we want to find out GCD and LCM? Okay, I will not give you a chance to prime factorize. Let me give it to you. 5 raised to 3, 7 raised to 5, 11 raised to 2. First number. Then 5 raised to 2, 7 raised to 6, 11 raised to 2. Second number. And third number, 5 raised to 3, 7 raised to 6, 11 raised to 3. Then GCD, LCM.
Sir, please just read. Indices are not visible.
Indices are not visible. 5 raised to 3, 7 raised to 5, 11 raised to 2. First number. Second, 5 raised to 2, 7 raised to 6, 11 raised to 2. Third, 5 raised to 3, 7 raised to 6, 11 raised to 3.
Thank you, sir.
दिसतंय सर?
नाही, सोपा प्रश्न आहे, त्यामुळे मी चेक नाही करत आता. राहू द्या. काय उत्तर? हा. Okay, should I make it little difficult? And let me add 3 raised to 5, 7 raised to 5. अरे कॉमा का टाकतोय? Fourth number is added. Now find out the GCD and LCM of these 4 numbers. 1, 2, 3, and 4.
Sir, is it visible? Yes, sir.
BCD 7 raised to 5.
Now, let me explain. We have got total 3, 5, 7, 11, and 13. These are the prime numbers that we have in all the 4. So we will write first number as 3 raised to 0, 5 raised to 3, 7 raised to 5, 11 raised to 2, 13 raised to 2. 13 raised to 0. This is our first number. We will write second number as, okay, 3, 5, 7, 11, 13. 3, 5, 7, 11, 13. 3, 5, 7, 11, 13. Okay. So second number, 3 raised to 0, 5 raised to 2, 7 raised to 6, 11 raised to 2, 13 raised to 0. 3 raised to 0, 5 raised to 3, 7 raised to 6, 11 raised to 3, 13 raised to 0. 3 raised to 5, 5 raised to 0, 7 raised to 5, 11 raised to 0, 13 raised to 2. These are the numbers. So GCD is equal to 3, 5, 7, 11, 13. The smallest amongst all of them. Index of 3, 0. Index of 5, 2, 0. Index of 7, 5, 6, 6, 5. 11, 2, 2, 3, 0. 13, 0, 0, 0, 2. This is GCD. So 7 raised to 5 is GCD. And LCM 3, 5, 7, 11, 13. The highest index 3. What is the highest power of 3? 5. What is the highest power of 5? 3. 7, 5, 6, 6, 5, 6, 11, 2, 2, 3, 0, 3, 13, 0, 0, 0, 2. Clear, everyone?
Yes.
Now I will just give you, we will not solve, but what can be a difficult question which can be asked on this? I give you one number and I give you GCD and ask you to find out all possible values of second number. I have taught you how to find out GCD and LCM. Then asking that is, easy question. So what I will do is, I will give you GCD and one number N1, and I will ask you to find out all possible values of N2, number 2, so that GCD of number 1 and number 2 is given number. This could be one way. LCM, I can bring it into the picture. And the still difficult if I want to make, I can give you GCD and I can keep A, B, C, D here and then ask you to find out what is A plus B plus C minus D. Instead of suppose 2 or 3, if I give 3 numbers and GCD LCM is given to you, then I can play with these indices. Some of them I give you, some of them are unknowns, which you should fix. Then you will get the values of unknowns, which is A, B, C, D, and then I ask you final answer, what is some combination of A, B, C, D. So unless and until we have the concept clarity, we won't be able to solve those type of questions. If time permits, in the end, we will try to solve few like that. Okay, but now let us move. 8:16. Any doubt, difficulty in this?
No,
sir.
no, sir.
Let us look at divisibility tests. Now we have understood the importance of divisibility test. We have to be efficient in prime factorization of any natural number given to us. If we have a divisibility test, then we will be efficient. So, what is the divisibility test of first prime number 2? What is the divisibility test of first prime number 2? सगळ्यांना येत असणार?
Yes, sir.
Yes. Huh? The number should be even.
Yes, yes.
Yes.
Any other way of saying the same thing?
Number ending with 2 and 0.
Number ending with
You
0,
need
2,
test ending with 0 or
0,
0, 2, 4, 6,
6,
8.
8.
Very good. Any other way of saying same thing?
No.
No. Okay. Now, when we are going deeper, let us write the divisibility test of 2 like this. The number n and last digit of n leave same remainder. Remainder म्हणजे मराठीत बाकी. Leave same remainder when divided by 2. In case remainder is 0, we say that n is divisible by
2.
We call this as complete divisibility test of 2. Completeness is there. Is this true? Suppose we have number n is equal to 23. 23 when divided by 2, how much?
Reminder is
1.
1.
We divide 3 by 2, how much will be remainder? 1. Correct? So we need not have to divide the entire number by 2 because actually we are supposed to do that. So the divisibility test says don't divide the entire number by 2, divide last digit by 2. If you happen to get remainder 0, then 2 is a factor. If remainder is 1, then it is not a factor. It is not divisible by 2. Okay. In case of 2, it sounds stupid, but it is very important because exactly same wording is going to be useful for so many other tests. Let us look at test of 4. What is the divisibility test of 4? ज्यांना आठवत असेल त्यांनी नाही आठवत असेल तर काय त्याच्यात फार मोठं नुकसान नाहीये. आपल्याला आता समजेलच काय. अरे मी कधी थांबणार आहे या लोकांना ऍड करण्यापासून. What is the divisibility test of 4?
Last two digit must be divisible by 4.
Last two digits must be divisible by 4.
Last
So,
two digit number.
last two digit number should be
Number.
divisible. Yes. So, divisibility test of 4. 4. The number n and the last two digits. Last two digited number. लास्ट टू डिजिटेड नंबर असं नाही म्हणत, लास्ट टू डिजिट्सच म्हणतात.
Last two digits.
Sir, ending with two zeros also divisible by 4.
Yes. We are writing bigger than that. Last two digits. Okay, last two digits represent two digited number represented by last two digits of n leave same remainder when divided by 4. In case remainder is 0, we say that n is divisible by 4. Correct? Now the question is, why is this divisibility test true? Let us find out. 23. नाही, जरा मोठा नंबर घ्यायला लागेल. 2357. Okay. Yeah, sure. This is not divisible by 4. So let us find out what is the remainder. When 57 is divided by 4. Correct? 60, 15 चौक 60. त्याच्यापेक्षा 3 ने कमी आहे. 1.
Remainder is 1.
Remainder.
Remainder is 1.
56 is divisible by 4. So remainder will be 1. And we check by actual division. 4 5 20. 35. 7 चौक 28. 8 9 चौक 36. 8 चौक 32. बरोबर. तोच येतोय.
4 9 जा सर 4 6
Sir,
जा नाही
nine
4 9 जा
काय झालं?
nine जा
4 9 जा
Okay, correct. Quotient. But the remainder is 1. Good. Now we need to figure out why it is working. Why is this test working? What is the divisibility test of 8? Last three digits should be divisible. Last three digits should be divisible by 8. Or number n and last three digits of number n leave same remainder when divided by 8. In case the remainder is 0, we say that the number is divisible by 8. So why are we getting something like this?
Because 4 is a 2 square and 8 is a 2 cube. Maybe.
4 is a 2 square and 8 is a 2 cube.
So 2.
2 is a factor of 4 and 4 is a factor of 8. And also 2 is a factor of 8.
नाही, पण तुम्ही खूपच हुशार आहे, म्हणजे पुढचंच बोलताय सगळं, म्हणजे त्यामुळे ते मला कळत नाहीये. 2 square is 4, 2 cube is 8, हे सगळं बरोबर आहे. पण it is last. Why should now last two digits 57, when we actually divided it was 37 here. है ना? They are not same, but still the divisibility test is saying that last two digits, whatever remainder that you will get, eventually when you divide a big number, this is small number, eventually you will divide a big number by 4, you are bound to get the same remainder. Quotient we are not interested. I mean, quotient जो असेल तो असेल. We are more interested in remainder. So 2 square is 4 is a correct statement, but it doesn't make any sense as far as trying to explain why is this happening.
Sir, our number system is based on the place values, and last three digit is like 1000. 1000 is divisible by 8. That's why we can say that number is also the whole number. We can for divisibility test of 8, we are checking with the that number only, last three digit only.
Yeah, I mean, you know something, but still the explanation has to be in such a way that everybody understands.
Sir, can
Okay,
I,
last three digits
can,
means 1,000, last two digits means 100. Yes, we understand.
Yeah, 1000 is divisible by 8 and we are getting the answer as a 125.
Yes.
sir, can
तुम्हाला
I try?
समजलं ना? समजलं म्हणून. Yes. Any other explanation?
Sir, can I try?
Yes.
Sir, what you can do is if you remove the last three digits, subtract the last three digits in terms of place values, the remaining number is a multiple of 1000. It is divisible by 8. Now the remainder is only consisting of the last three digits number. So if that is also divisible, the entire number is divisible by 8.
Correct. Okay. Very good. So now we need to figure out how do we get the remainder when we divide any natural number by another whatever natural number that we are trying to find out as a divisibility. Barabar? So let us take a couple of steps in the backward direction and find out when we divide a number by another number, what do we do? Okay. Sure. When we divide 23 by 4, the physical meaning of that is I have got 23 notebooks and I am supposed to divide it in 4 students. How many each will get? That is what is the real life problem we are solving, and that is where the division comes in picture. So I start giving one notebook to each. I have 23, so first round of distribution is done. Everybody got one notebook each. I go another round. Yes, yes, yes. Therefore, when we are actually dividing 23 by 4, we could complete 5 rounds by giving one notebook each. And hence, I have consumed 20 notebooks and 3 notebooks are left with me, which I cannot distribute. Therefore, we call those 3 notebooks a remainder. Unless I get something, I cannot distribute because I want each one of them to get equal. This is what that remainder is. Now, suppose I do exactly same exercise. So this is what the work which we did. We can write it as 23 is equal to 4 into 5 plus 3. Right? But then suppose I do not know the long division and I do this multiplication by division by like this. Then my remainder is 11. My quotient is 3. 23 is equal to 4 into 3 plus 11. This statement is true. So should I call this 3 as remainder or 11 as remainder, or if I am allowed to use some negative number, then I will put 7, such 28 minus 5 is a remainder. The statement is this is equal to 4 into 7 plus minus 5. All these statements are correct.
Sir,
Right?
division algorithm. Division algorithm, na?
Exactly like young kids, we are interested in spelling out the answer. Anyway, okay, so the word she is using is correct, but then I want to develop that word. I mean, this is a procedure that we are following for solving our physical problem. I wanted to give 7 notebooks to each one of them 4, but I have only 23. Might as well go and buy 5 more and come back. That is the meaning of this division. I wanted to give 3, I gave, so I'm left with 11. Correct. I wanted to give as many as I can, but I can give maximum 5. Okay. So in maths, our elders have decided that this is the correct one. And this is not incorrect, but this is incomplete. Because in division, you are expected to keep doing it till you cannot. And then this is wrong because you don't have something which you want to distribute. So this is wrong. So you have to stop here. So all these equations are correct, but the correct procedure of dividing is this, and it's called division algorithm. So if we want to really write down the statement of division algorithm, which we are not going to write, but we want to understand, then what could be that important word, important statement that we should have? Mic band kara. The important statement that we should have in our discussion is we have to talk about the remainder.
हा सर
जरा थांबा. If this is the only statement which we are going to take it correctly as a correct, and these are not correct, I mean not complete. Rather, these statements are correct. This is not complete. This is not complete. This is not acceptable. This is not acceptable. And there will be infinitely many ways of doing this. Amongst all of them, we will approve only this as a division. That is what we have been doing so far. So if we want to approve this as a division, then suppose this number is n, suppose this divisor is d, suppose this quotient is q, and this remainder is r. What is the condition that we are going to put on any of these?
R should be less
What
than.
is the condition that we should put on R so that our division algorithm is complete? How should our R be?
सर
Less
R
R
is
is
less
less
than
than
Greater
divisor.
than dividend.
Less than
Minimum is not the correct word.
Highest possible.
This
Less
is
than.
smaller. This is smaller than this. Yes.
Highest possible.
R should be
less
and
than,
greater than equal to
Greater than.
0. Our remainder must be between 0, equality allowed, and D, inequality not allowed. 0 should be less than or equal to R, should be strictly less than D. Is your division. This is division algorithm. I mean, in book it will be given in such a complicated way that we will stop reading the book after that. It is very simple idea. Very simple idea. You stop when your remainder is smaller than divisor. Until you get positive remainder, keep doing it. This is division algorithm for number theory. We will have division algorithms for polynomials and other branches. There we have to define exactly at that time, but here it is like this. And therefore, in spite of the fact that this algebra is correct, this division is wrong. This algebra is correct, this division is wrong. Okay, so if we understand division algorithm, then we suppose I was to distribute 23 notebooks in 4 students, but today I have got only 13. And next day I have got 10. Total I have got 33, but today I have only 13. I started dividing, I started giving to 4 students. So 13 plus 10 is 23, correct? I wanted to distribute 23 notebooks in 4 students. I am aware by previous calculations that I am going to be left with 3 notebooks not distributed. But first I have 13, I distribute, and I realize that I am left with 1 when I distribute 13. Then I got 10 more and I realized that I am left with 2. And when I distribute 23, I am left with 3, which happens to be summation of the remainders. Observation. Total 23 were there, I distribute, I end up with 3 with me. But first 13, then 10, 1 plus 2, 3. Correct? But it is not always correct. Why? Suppose instead of 13, I have got 15 first, followed by 8. नाही 14 plus 14 first. तर इथे किती राहिले 4 त्रिक 12 म्हणजे 2. हा नंबर छोटा आहे म्हणून मीच बसतोय. थांबा 108 is equal to. Now what I am trying to get is, let me get the addition of remainders bigger than 4. Give me a number which will leave remainder 323. Will leave remainder 3. One more number which will leave remainder 343 plus किती झाले 66 gone 6 म्हणजे 40. Suppose we break 108. Fortunately 108 is divisible. 108. Okay, 110 करूया. Not divisible by 4. This should be, last one should be 4.
44.
Suppose I wanted to distribute 110 notebooks, but first I got 23. So I am left with remainder 3. Then I have got 43. I am left with remainder 3. And then I have got 44. I am left with remainder 0. Correct? So 3 plus 3, total 6. But this will leave how much remainder?
2.
Which is not true. गोंधळ आहे. मग काय गोंधळ आहे?
Again, find the remainder of our addition.
So whatever we are left in the first batch and in the second batch also can cater to our distribution, and therefore 6 divided by 4 is equal to 2. The second level remainder, not the first level, but second level remainder. If you keep finding out the remainders of RHS, eventually remainder of LHS and remainder of RHS, left hand side and right hand side, they are bound to be equal. Because it is the same number. I mean, equality means it is the same number. Here we are calling it 110 and here we are calling it 23 plus 43 plus 44. We are just saying another way. It is the same number, equality. Therefore, whatever number, this number leaves remainder when divided by 4, this number also is supposed to leave the same remainder. No matter how many ways we break it, it is going to be the same. So therefore, divisibility test of 4 says, suppose my number n is equal to 5398237052. 7. Now, if we keep dividing this number by 8, it is going to be time consuming. Therefore, we break this n in 5398237000. Let us make this 9000 plus
527.
527. Now we need not worry about this big number as far as divisibility of 8 is concerned, because this is multiple of 1000. 1000 is divisible by 8. So because we have brought 3 digits in the end, the remainder without division by 8 is 0. लक्षात येते? And therefore remainder of n when divided by 8 is going to be equal to remainder left by last 3 digits of that number. So we break the number in parts for our convenience. And it is now you will save a lot of time to find out the remainder of this number when divided by 8 if you do only this. Therefore, it is divisibility test, efficiency criteria. Dividing 527 is easy by 8 rather than the big number. लक्षात येते? And therefore, for 2, the elder brother is 10. Therefore, you just look at last digit. For 4, the elder brother is 100. Look at last 2 digits. For 8, 1000. Therefore, for 2 raised to n, 1, 0, 0, 0 is going to be your elder brother n times. So we are done with divisibility test of 2 raised to n. N varies from 1 to whatever number you want. This divisibility test will work. Of course, for bigger numbers, it doesn't make sense because dividing last that many digits itself is a problem. But theoretically, yes, this is a divisibility test of 2 raised to n and it is going to work. सगळ्यांना
Instead of dividing by 8 by looking at last 3 digits, and we still look at last 2 digits, but like 2 tests, divide by 4 and divide by 2. Instead of 8, we say 2 and 4. And apply on the last 2 digits. If both there is a remainder 0, then we can still say that we can do it.
If the number is divisible by 4, it will be divisible by 2. It will not give you additional information.
Yes, and right?
No, but what will you do actually? Tell me, by using 4 and 2 test, tell me what is the remainder left by this number.
So 27 divided by 2.
1. Remainder is 1. No, yes or no, we are not saying. We are saying remainder left because it has got some additional advantages. Yes or no, I mean, maybe it will work. Yes or no. But as far as finding the remainder is concerned, it is not going to work because of the fact that 2 will divide all those numbers which 4 divides.
512 is whether it is divisible by 8 or not. Now it is divisible by 8. But 12, now if we take
12 is not.
12 is not divisible by 8 with the logic that
But he's saying last 2 digits should be done for 4.
4. Actually, it is divisible by 4.
Yes.
It is divisible by 2.
Yes.
And then we say, yeah, now it must be divisible by 8.
Yes.
That might take 2 hours.
This one can be said the number is by 16. If last 4 digits are divisible by 16.
Yes. That is what this 2 raised to n is. When n becomes 4, it is 10,000. Because of 10,000, it will be working last 4 digits. Correct? Little difficult, but if you really pay attention, it is very, very easy. Have you all understood? Online students? Yes. Then I have a question. Then I have a question for you. We have written this test. I have got 2 tests written over here for 2 and 4. And maybe I can add a few more also now, 2 raised to n. Right? If I don't want to change the wording of this divisibility test and only change few numbers here, like I have changed 2, like I have changed last 2 digits and 2, these 2 places. I don't want to change much. Can I produce one more set of divisibility tests? Totally different than what we have done. Can I generate a new set of divisibility tests using whatever work we have done in last half an hour? By the way, माझं घड्याळाकडे लक्ष आहे का? 16 मिनिट.
Sir, in last 2 digit, we can replace by sum of digits. The divisibility rules for number 3 or number 9.
No, I am not asking some new divisibility test. No, we will discuss them. What I am trying to say is the wording is same. And we have exhausted with 2 powers of 2. Can I use the same wording for generating altogether new set of divisibility tests for some other numbers?
So it can be divisibility test of 2 power n. The number
We have done that. We have done that.
Divisibility of 10
नाही.
So 5,
Five?
divisibility 5.
हे नुसतं दगड मारत सुटलंय. थोडा विचार करून करा काय ते. कधीतरी उत्तर बरोबरच येईल ना. सुरुवातीचे काही नंबर उच्चारत बसलो आपण. 8. What is our logic? What is our logic for these tests? Why are they working?
2 raised to x.
Why are they working? What is the logic for divisibility test of 8? Last 3 digits. 8 is 2 raised to 3. Last 3 digits of the number of the big number is anyway divisible. What remains is last 3 digits. That is what is our logic here. The same logic is going to be applicable for the test of 5 raised to n. What is the divisibility test of 5? Last digit should be 0. I mean, last digit and the number will leave same remainder when divided by 5. What is divisibility test of 25? Last 2 digits and the number will leave same remainder when divided by 25. What is the divisibility test of 125? Last 3 digits and the number will leave remainder, same remainder when divided by 125. Do you realize why it is? Because 8 is one of the factors and another factor is 125. Of 100, one factor is 4, another factor is 25. Of 10, one factor is 2, another factor is 5. So when we generated divisibility test of these people, automatically these divisibility tests are generated. Whether they are required, whether we will use it or not, doesn't matter. But they are available. Are yes or no?
Yes, yes.
And we need not have to spend any energy.
Yes.
The logic is already explained. We have looked at one factor, we should look at the other factor. That's all. Logic is exactly the same. Therefore, we have a set of divisibility tests for nth power of p, 5. Nth power of 5. And the divisibility tests are going to be complete divisibility. The number and the last 2 digits of the number leave same remainder when divided by 25. चालेल, मग नोट करून घ्या आणि अजून काय करता येईल का बघूया आपण 12 मिनिटांमध्ये. हा, एक ऍप्लिकेशन दाखवतो तुम्हाला याच. ओके, नोट नका करू, वेळ जाईल. ऍप्लिकेशन दाखवतो. Three 7925423. Suppose this is number n. It is too big. Is this number, can this number be perfect square? आता 12 मिनिटात संपणार, 11 मिनिटात संपणार काय हा प्रॉब्लेम नाहीये. What we will think is we should first prime factorize it, which itself is going to be very difficult, time consuming, because there are very bad digits over there and anyway it is 9-digit number. So first task itself is very difficult to prime factorize. Then after prime factorization, if we look at the indices, if all of them are even, then we will say yes, this is a perfect square. If any one of them is not even, then it is not a perfect square. Correct? हे तर आपण शिकलोय already. When do we recognize a number to be perfect square or not? But now, with the divisibility test that we have learned so far, I can say that this is not a perfect square. This is not a perfect square. Now, the test that you know, suppose instead of deliberately I have put this 9, suppose I put it 7, then you will also say that this is not a perfect square. Why? Because perfect square will not end with digit 7. That is correct. Very correct. And therefore, deliberately I have put the last digit 9. Perfect square can end with 9. Correct? Actually, prime factorizing this is going to be almost impossible, extremely difficult. It will create some error or the other while calculating. So, we wish to find out the future of this number. And we use divisibility test of 4. 4. All natural numbers 1, 2, 3, 4, 5, 6, W dot dot dot. All natural numbers can be divided in 4 groups using divisibility test of 4. Leaving remainder 0 will be one set of natural numbers. Leaving remainder 1 will be another set of natural numbers. Leaving remainder 2 will be another set of natural numbers. And leaving remainder 3 will be another set of natural numbers. So those who are leaving remainder 0 when divided by 4 will look like 4k, where k is another natural number multiple. So 4 times k. If k is 100, this is 400, it is divisible by 4, it leaves remainder 0. Samajhte? If k is 3, then this number is 12, it is divisible by 4, remainder 0. So all those who are divisible by 4 will look like 4k. All those which will be not divisible but leaving remainder 1 will look like 4k plus. Remainder 2 will look like 4k plus. Remainder 3 will look like 4k plus. So these are all natural numbers. These are all natural numbers. They are infinitely many, but we have listed them in 4 categories. Okay. And now we are talking about squares of natural numbers. By looking at the number, we should find out whether it is a perfect square of some natural number or not. Therefore, what do? We square all of them. So what is the square of 4k? 16k square. What is the square of 4k plus 1? 16k square plus 8k plus 1. What is the square of 4k plus 2? 16k square plus 16k plus 4. And what is the square of 4k plus 3? 16k square plus 24k plus 9. Okay, we have got all natural numbers. We have got squares of all natural numbers.
Any number can be represented as 4k plus 150.
Why assumption? True, na? Any natural number will be divided by 4, will leave remainder either 0, 1, 2 or 3. Nothing else. No fifth remainder, only 4 remainders. So these are the squares of all natural numbers. Now let us apply divisibility test of 4. This number will leave remainder how much? This leaves remainder 0. This number will leave remainder how much? 1. This number leaves remainder 1. How much this number will leave remainder? 0. And how much this will leave when divided by 4? 1. So if a number is a perfect square, then by applying divisibility test of 4, you should get either 0 or 1. You cannot get 2 or 3. If you are getting 2 and 3, that means it is definitely not the perfect square. The given number leaves remainder 3 when divided by 4. So this is negative test. This number is not perfect square. If this was 8, then we don't know is the answer. Because it will leave remainder 2. 2 पण चालणार आहे. So no, still not. If it is 8, पण 8 आपल्या युनिट प्लेसला नसतोच ना तिथे, त्यामुळे डेफिनेटली नॉट. But if this is 7, because of unit place it will go. But if this is 6, if this last digit is 6, we will not say this is a perfect square. कारण आधीचे कोण आहेत कोणाला माहिती. If the last digit is 6 instead of 9, we will say it may be a perfect square, it may not be a perfect square. by applying divisibility test of 4. I am aware this is done little fast. We will discuss this in the next lecture again. आहेत अजून 5 मिनिटं. कोणाला नाही समजलं तर विचारा. काय बोललो मी?
Sir, I lost you at the last step. After you got them into the form of 16k square and the other equations, the 0, 1,
Yes.
0, 1 part, I lost you.
So you did not understand this?
Yes, I did not understand this.
Okay. This is all natural numbers together. This is natural set of natural numbers. This is set of all natural numbers squares. Have you understood this? Now we apply divisibility test of 4. And it is easy to apply here because 16k square is going to be divisible by 4. Therefore, remainder left is 0. 16k square is divisible by 4. 8k is divisible by 4. Therefore, remainder is 1. 16, 16, 4, remainder 0. 16, 24, 9, remainder 1. So only 2 types of remainders are available. So we have scrapped 50% of natural numbers from being perfect square.
Got it.
50% of natural numbers are scrapped for being perfect square because they will leave remainder 2 or 3. If your natural number is to be a perfect square, it must leave remainder 0 or 1. So this is negative test, but very useful. You will not be able to realize when this is 39 in the end, the guesswork is not going to work, but divisibility test of 4 will give you. Now, homework, you find out similar application for using divisibility test of 3. Can we scrap few more natural numbers from being perfect square or not? And for that matter, every divisibility test, because it is complete divisibility test, we talk about remainders. We just don't talk about remainder equal to 0 in the divisibility test. That divisibility test has more applications and better understand. That is where we stop for the day.
सर तो स्क्रीन
Sir,
रेकॉर्ड
please
करू शकता
एकच
का?
विचारू
Screen
का?
save करून पाठवतो. Yes.
प्लीज
Sir, we apply the divisibility test for 3 on the same number, or we
Yeah, you can apply on same number,
on the same
or
number?
you can create few more numbers and apply it.
Got it.
Thank you.
Sir,
See you
एकदा
on
प्लीज
Tuesday.
सांगा ना, 4Ds आपण का सुरू केलं?
काय म्हणताय?
आपण 4Ds का सुरू केलं? मला थोडे बदले 2-3 सेंटेन्स बहुतेक मिस झाले.
नाही 4 नेच का सुरू केलं? कारण
हा.
4 ने जास्ती इंटरेस्टिंग आहे म्हणून पुढच्या लेक्चर पुढच्या मंगळवारी आहे, सगळ्यांनी या.
हो सर, नक्की. खूप छान वाटलं सर आजचं लेक्चर, भारी एकदम. थँक्यू.
Thank you. I
सर
am ending the meeting. See you next Tuesday.
सर जीसीडी आणि एलसीएम साठी काही होमवर्क मिळू शकेल का? थोडी प्रॅक्टिस पाहिजे असं वाटतंय.
बघतो सापडलं तर पाठव.
हा चालेल. थँक्यू.
सर शेवटची कन्सेप्ट एवढी नाही समजली.
नाही कळली सर मला.
We will repeat.
पुढच्या लेक्चरला प्लीज रिपीट कर.
Yes, we will repeat.
Lecture.
थँक्यू सर.
नाही.
थँक्यू सर.
Thank you.
Thank you, sir.
Thank you, sir.
And
थँक्यू.